Start the recording again. Okay. So as I said, the objective today is to know how to approach the problem. So the first thing that you need to look into it is what is the technique that you are asked to use? Because if you use another technique, you will get 0 in the question. So pay attention. What is the technique you have to use? Here it says using KCL and KVL. Then this is the first thing in any question. You have to read carefully to see what is the technique that you are required to use. Okay. Now, if this is KCL and KVL, then regardless what is required, you forget what is required in the question. Then you need to assign currents in every branch and call it, for example, this is I1, I2, and I3. So this is the first thing. You need to assign currents, and then you start to apply your KCL and KVL. So first you have to assign certain, if it's not assigned in the question. Okay, now you have to know one thing here. You cannot solve any problem except if it is just one loop. You have to use both KCL and KVL. KVL alone will not be sufficient. KCL alone will not be sufficient. So at least one KCL or one KVL, it has to be in the set of equations. So here we see how many variables we have. 1, 2, and 3. So we have 3 variables. Then you know in advance that you need 3 equations. Okay, so we'll see here KCL, apply KCL. There's something wrong with this. I don't know what's wrong with it, but let me try to. So KCL apply to node number 1. So I1 is equal to I2 plus I3. Current enter the node equal to the currents leaves the node. So this is the first thing. Now the second thing is the KVL. There is no any other KCL I can apply. There is no any other KCL because this is the only node I can apply KCL. This node will give me exactly the same thing. This node is not helping anymore because I1 here, I1 there, so this is not really helping. Now, then you have to assign polarity based on the current direction, and polarity are giving to you plus, minus, plus, minus, plus, minus based on the current direction. So we need to apply KVL. So now we have here one loop. So KVL to loop number 1. Okay, so now we need to use here KVL along with Ohm's law. So the first voltage here will be I1 R1. Move on, plus I2 R2 minus Vs equal to 0. So now R1 and R2 and Vs are all given. So the only unknowns are I1 and I2. And here I1, I2, and I3. So we need one more equation. Now I can take the bigger loop or the smaller loop. Any of them will do the job for me. So I will take this loop, the smaller one. And I will call this is KVL to loop number 2. Now we go, and as I mentioned before, you can go clockwise or anti-clockwise. It doesn't really matter. So this voltage is I3 R3, go around, minus I2 R2 equal to 0. So now we have 3 equations, 3 unknowns, then I'm done. Then I can solve them. Now it becomes a math problem. You have to know that 60% of the grade on setting correctly the equations, 40% would be on solving them to the end until you find the final answer. And if you do mistakes, either in the first step or the second one, it depends how severe is your mistake, there will be some penalty. This is why it's a must that you have to submit your final your complete answer as a PDF file. It's not just sufficient to enter the answers in the quiz format, because the exam you will submit the answer in two different formats. When you solve the question, you will find a blank that you need to fill the number or numbers that you have to enter, and you don't need to enter the unit. The unit will be given to you in the beside this box that you enter the number. Now, every questions you enter, so as we said, we have 6 questions. So this will be the first or one of the questions, the KCL, KVL. Doesn't have to be the first. Okay. Then you have to write down everything on whatever format you like, and you have all the questions saved as one PDF file, and then you submit that. So you have to submit the answer online, but this is just to show that you have entered the exam and you have submitted your answer online. But also you have to submit everything as one single PDF file with all the steps. Any question here, guys? Any question? We see here. Okay. So I will be moving question from one to another. If you have any concern about the generic approach of the problem, please let me know, because this is the objective of our tutorial today. Let's see this question. There's one question here. We don't need to show our work for MC. No, for the multiple choice, you don't need to show anything. You don't even need to write them on the piece of paper. The multiple choice questions, they are yes or no. That's it. So you have to enter the answers online, and that's it. And you don't need to submit anything. So you need to write solution for 5 different questions only. Okay. The second type of question is to find R equivalent. And here you have to identify, this is the most important thing. What are the resistors that they are connected in series, and what are the resistors connected in parallel? And usually you come from this side, not from the other side. So you come from this side to see this. If you come from here, you don't see anything in series or in parallel. So what I suggest for this question, first identify any components that they are connected in series or parallel. Okay, how to tell if they are in series? They are in series if 2 elements share one node and nothing else share the same node. And when you look here, you will see that there is nothing connected in series, nothing at all. No connections in series whatsoever. For example, this node, it have 1, 2, 3 elements. If 18 kilo ohm was not there, then the 6 and the 9 would be in series. So nothing connected in series. Then we'll check, is there anything connected in parallel? Okay, how do I know? Parallel when the 2 elements shared the 2 nodes. So let's see here. Okay, so can you figure out something that is connected in parallel, guys, here? Sorry. Do you think, can you see anything connected in parallel? Nine and 18. Yes, exactly. 9, 18. No, 6 and 18 is not. Because let's see the 6 and the 18. This 6 shared with the 18 one node, but the other node is not shared with this 6, shared with the other 6 kilo ohm. But the other node of the 6 kilo ohm is not shared with the 18. So none of them. But see the 9 and the 18. They have this node, and they have, with all of this, basically it's just one node. All of this. Just one node. So it is extremely important that when you work on this is to redraw the circuit. every time you do any modifications, redraw it, you can easily visualize. So for example, in this case here, this 8 and 9 will be in parallel. So we'll have here the 12 on top, 12 kilo. Okay. Now we will have here this is how it would look like. This is your A, and this is your B. This is the 12. This is the 6. This is the 6. And here is the equivalent of the 18 and the 9, which is another 6 here. Okay. So now it's very clear to me that, okay, now the 6 and the 6, they are in series. This 12 with this 12, they are in parallel, and then everything is in parallel with the 6. So it's very important, and this is what I strongly suggest the students who are working with a resistance question. Please draw each step so that you can visualize it. Okay. Now, how come I come with this? Now, let's see. These two are in parallel, okay, and there is 6. Now, how to figure out that this is how it look like? Okay, from one side, these two connected to the 6 kilo ohm, which is this node. Okay, so the equivalent has to be connected to the same resistors connected before, and at the other end, it is connected to the 12 and the 6. The other end connected to the 12 and to the 6. So your equivalent resistance should be connected to all the resistors exactly in the same way before you did any reduction of the resistor. So that's a way to confirm that your parallel connection, this is how it should look like. Once you draw it, it becomes extremely easy once you start to show the steps. And also when you show the steps as well, and this is very important, and this is applied to all questions, you have to show your steps. You cannot give me the final answer and just as a number and that's it. You will get 0. You have to show the steps, and I will be sending an email with all these regulations, uh, so that everyone is aware of them. You have to show every single step in your answer, so that when you show all the steps, first, it's for your own benefit because you will get partial marks. And if you did a mistake somewhere, your final answer will be wrong. It could be a very simple mistake. If you show only the final answer, you will get 0 because you don't show any steps. But when you show the steps, it's for your own benefit to give me the details of your answer. Any question here, guys, about circuit reduction? So more than two elements can be in series, right? Like all the 6 ohm. No, the 6 ohm resistors, these two are in series, but this is in parallel with the equivalence. Yani, let me try now to redraw this. So this is your 12. Then we have here another 12. Then we'll have here the 6. This is your 6. Now what you can see here, the 6, the 12, and the 12 all are in parallel, as a matter of fact. How is that? They share this node and they share this node. So all of these are in parallel. So you can say that 1 over RAB is equal to 1 over 6 plus 1 over 6 plus 1, sorry, 1 over 12 plus 1 over 12. Hopefully this is clear. Okay, now you will have one question. It could be current division or voltage division. You won't have both. Now, the same question, you could apply both. Okay, so you will see that the question, he said, using either or, sorry, and or. current division and voltage division. So you could use or one of them or both of them. So let's see, this is questions here. I mentioned clearly use current division. So when you look to this circuit, now we said one thing about current division. You have to have it in this format. You have to have one current source and two resistors in parallel, R1, R2, and I. This is how it should look like, your circuit. Now, your circuit here definitely it's not, doesn't look like this. First of all, we have two current sources in parallel. When we have current sources in parallel, you add them with the sign, meaning 5 up, 2 down, then you will have here total of 3 amps up, 3 milliamps up. So you can add and subtract the current sources if they are in parallel. You can add and subtract voltage sources if they are in series. Okay, so here it becomes just one current source. Now we keep the resistance. Okay, let's have a question here. uh, I missed that you says using both. You have to use both or just one. You have to add them. You cannot just have both of them. So you have to add them to have only one current source. So your circuit has to be looks like this one. Okay. So this is how your circuit should look like: a current source and two resistors. Now here we have two current sources. Since they are in parallel, then you can add them 5 up, 2 down, then total of 3 milliamps. And then you need to add everything. If you have two, 3 or more, you have to add all of those in parallel. I will call them as an R equivalent. And you keep the one of interest, the one that you need to find the current. You want to find the current in the 6 kilo. IL. You keep it, you don't touch this one, you keep it as it is. Now, see, you have this in this format. Now, your IL is equal to the current here, which is the 3 milliamps, times the other resistance, which is the R equivalent, divided by the R equivalent plus the 6 kilo. So this is how you do a current division question. Let's see the voltage division question. Now, to apply voltage division, you have to have a voltage source in series with, doesn't matter how many resistors. As far as the voltage source, along with the resistors, all of them, they are in series. R3, R4, R5. So you can find any voltage here if the voltage source and the resistors are in series. Let me see here. There's one question. It says here, what would we do with current source in series and voltage sources in parallel? Current sources cannot be in series unless they have the same value, because otherwise, let me explain to you why. If you have a current source here, 3 amps, in series with another source, current source, 2 amps. Apply KCL here. It says 3 equal to 2. Doesn't make sense. So what we'll be doing, if you have two current sources in series, you will damage the small rating one. You will force it to become. So we never connect current sources in series unless they are in the same value. Same thing for the voltage sources. We do not connect voltage sources in parallel until they have the same value. If you connect two voltage sources in parallel with different values, the one with the higher voltage will damage the other one. So voltage sources, because in parallel, they have to have the same value. Okay, if one is different, then one of them will force the other to take the same voltage, and physically, what does this mean? It will damage it. It will burn that supply. Now let's look here. This is an interesting question, because here you see a voltage source in parallel with a resistor, and then we have these two resistors. I want to apply voltage voltage division. Now, when you look here, what is the voltage across the 12 kilo ohm? It's basically this voltage source. So this is actually 6 volt because they are in parallel. And now this 6 volt, forget about now this completely because these are the same node. So the voltage between point A and B is 6 volt. Now, what will happen to this volt if this resistor that says 10 kilo ohm? What will happen to the voltage? Stay the same. If there is no, it's an open circuit, it will stay the same. So actually this resistance will have no effect whatsoever on the voltage between A and B. It will have an effect on the current that goes through it based on Ohm's law, but it will have no effect on the voltage. So I can just take it out as if it doesn't exist actually, because it will not impact the voltage. So basically now I have a voltage source in series with two resistors. Now, once I establish this, your voltage of 4 kilo, because this is what you want to find, V out, which is the voltage across the 4 kilo ohm, is equal to the 6 times the 4 divided by the summation of all resistors. As simple as that. This is how we apply KVL. Now, sometimes the circuit is not really exactly the same. Let me give you this example and let's see your thoughts, how you will handle this question. If you have something like this, R1, R2, R3, and I want to find V1, and this is your Vs. What do you think, guys? How we can handle this question? And I said using voltage division, how you will handle this question? How to find V1? Exactly. Thanks, Violet. Uh, you have to combine these two. You have to first put it in that format. It doesn't matter how many resistors are in series. So these two are in parallel. So you have them as one equivalent resistance. Now we have everything in series. Then you apply. So in conclusion, for current division and voltage division, you have to simplify the circuit until you have a voltage source in series with resistors or a current source when a parallel with two resistors, and then you apply the rule. So you might need to do some sort of uh, reduction of the circuit before you do any before you proceed. So now we covered 3 different questions out of the 5. Okay, now let's see the nodal analysis. Or before that, let's see the strain gauge. Now the strain gauge, in my opinion, this question is like the super easy one. What do I mean by the super easy one? It's just one formula, and we have it here. Of course, you can write it down on a piece of paper. And this formula calculate the voltage V out, the voltage that is produced in the open circuit. Now, if the Western bridge is balanced, this voltage is equal to 0. Now, we need to specify the following things in any string gauge question. The first thing you need to know, how many strain gauges you have. Okay, 1, 2, or 4. Okay, then where is the location of the strain gauge? You need to know the location of the strain gauge with respect to the R's. Okay, so this strain gauge, is it R1, R2, R3, R4, or if there are multiple of them? So you have to know which strain gauge in which R. Okay, because this is very important to find the V out, because the resistors that are replaced by strain gauge, their value will change. Resistors that they are just resistors, their value will not change. Then you need to find, you need to know this R will change to R plus delta R or R minus delta R. So based on the force direction, you need to know that will this R or this string gauge will be elongated or compressed. If it is elongated, then R will increase. If it is compressed, then R will be going down. And that's it. That's all you need. You don't need even to simplify the formula as we did when we derived. Just substitute. You need to know, okay, how many string gauges? Two. Okay, excellent. We have two string gauges and two resistors. We have a total of four. Okay, where is the location of the string gauges? Let's say it's R1 and R2. Okay, so R1 and R2, their values will be changing. R3 and R4 will be fixed. So don't touch R3 and R4 in the formula. Now, will R1 will be increasing by a delta R or reduced by a delta R? That's all you need to do based on the force. Now, when the R1 over R2 equal to R3 over R4, then your Wheatstone bridge is balanced and your voltage is equal to zero. That's all you need to know about this question. Comes to the last one. You will be okay. There's a question here. Let me answer this question. It says here, how do you find where the location of the string gauge with respect? You will be told that you have a string gauge 1 connected as R1, string gauge 2 connected as R3. So these things are given to you. So the string gauges will be numbered on the beam, but you will be told that this string gauge corresponds to which R. So you don't need to figure out this by yourself. No, it doesn't have to be R1 equal to R3 equal to R4 equal to R. This is why I said you don't need to derive a formula. If you come here, you just plug in the numbers here. So you don't have, what you will find that when there is no any force, R1 over R2 equal to R3 over R4. This is always, but they don't have to have the same values. You could have the same value or not, and it doesn't matter. As far as you come here and you substitute values, that's all you need to do. So that should be no problem. Okay, let's come to the last question, which is the nodal analysis. I asked the TA to make it easier for you to specify the ground point. So you don't need to figure out this ground. So it will be given to you. So all questions, you will have the ground point specified where your voltage is equal to zero. Now, in the nodal analysis, regardless what I ask you to find, you find the current, you find the voltage, you find the power, you don't care. Even you don't need to look into what I ask you to find. What you need to do, specify the ground. This is already specified. Then specify the n-1 nodes and give them numbers. V1, V2. That's it. Okay. And then apply KCL at each node that does not have voltage source. So you will apply KCL for that. Now, when you apply KCL, okay, let's see here. In terms of node voltages, this is why I call it nodal analysis. In terms of nodal voltages. Okay, so here we assume the currents are leaving unless it is a current source. If it's a current source, I cannot touch it. So here, apply KCL. So let's see here, KCL at V1. Please, when you solve, make sure you identify at what node you're applying KCL. You can number them or you can refer to the voltage number. That would be sufficient. So now you see IX. Forget about IX. I don't care about IX. What I care here is to have a KCL in terms of V1 and V2. That's all. Anything else, I don't care about it. So this current going down, it becomes V1 divided by 12K plus this current going to the right, V1 minus V2 divided by 12K, and then this is minus 12 milliamp equal to 0, one equation, two unknowns. Okay, so I need one more. So I will apply KCL here. KCL at V2. And we said now, when you are at V2, assume again all currents are leaving. It doesn't really matter if you assume the current entering the node in the previous step, but you can now assume all the currents are leaving. Okay, so currents to the left, V2 minus V1 divided by 12K. Current down, I0. I don't care what is this I0. Plus V2 over 12K plus, and this is current is leaving 4Ix equal to 0. And this is equation. Okay, two equations, but now I have Ix. Okay, so now I have a third unknown, so I need a third equation. Now, whenever you have a dependent source, this will introduce another unknown. Okay, so what should we do? What is this Ix, basically? This Ix is this current in that direction, going in this branch. So Ix itself is basically nothing but V1 over 12K. That is your Ix. So you come here and you substitute your Ix with its value. Then you will have two equations, two unknowns, you solve them. So your first task is to find all nodal voltages. Now we found them. Okay, now let's read the question. Okay, in the following circuit, find I0. So the question is asking for I0. What is this I0? Your I0 is, okay, I will come to this. Your I0 is this current, so which is V2 over 12K. Now you already found V2 before, then you can find I0. Now what is this Ix? Now here remember, we applied KCL at V2. Okay, assume the currents are leaving. V2 minus V1 over 12. V2 over 12 plus 4Ix. Now Ix is a variable. We don't know its value. So now we are adding a third variable. We have here two equations. We have three unknowns, V1, V2, and Ix. So I need to find the Ix in terms of the voltages or the nodal voltages. So my Ix is this current, which is basically V1 minus 0 over 12K. Then I can come and substitute Ix with V1. So now I will have two equations with two unknowns and I can solve them. Okay, so this is why we need to do that. So here, the most important point in nodal analysis, do not get overwhelmed with what is required. Don't even think about it. If this is a nodal question, forget about what I ask you to find. Okay, I need to find all nodal voltages. Set the reference, which will be set for you. You don't need to worry about it. V equal to 0. And for your information, usually we select the bottom one. This is usually the the norm here, and usually it is the one that connected to the negative of the voltage supply. Here we don't have any voltage supply, a voltage source, so we use the bottom. Always very convenient for us to do that. Okay, and then you find every single node voltages, which is n minus 1, because at the ground V equal to 0. So I already know the voltage. So I need to know the voltages on all other nodes. Once I know V1 and V2, I can now see the question, okay, what you want me to find? It could be find the nodal voltages. It could find, for example, the question could be find this voltage, this polarity, well, Vx. Can someone tell me what is this Vx will be? What will be this Vx? If the question was find Vx, what would be Vx? So it's using nodal analysis. It says find Vx. Go ahead. You can talk, guys. I think Vx is equal to V1 minus V2 over 12 kilo ohm. Okay, how do you think, guys, about this answer? V1 minus V2 over 12 kilo ohm. What do you think, guys, about this answer? Right or wrong? Wrong. That's current. Exactly. Voltage over resistor is a current. I want to find a voltage. So what would be the voltage? Again, what is Vx? Can someone give me the right formula for that? Assume that we found V1 and V2. So what will be your Vx? It is V2 minus V1. Excellent, Violet. Okay. So it is V2 minus V1 because of the polarity. Here is the polarity, plus, minus. You have to note where is the positive, where is the negative. So it is plus minus here, so this becomes V2 minus V1. If the polarity was the other way around, it would be V1 minus V2. So it's very, very important to know that. So as you can see here, nodal analysis, find the nodal voltages. You have solved 90% of the problem. Then, once you know the nodal voltages, let's see what exactly is requested in the question, and then you can find that easily. And basically, you will apply mainly Ohm's law. That's what you need to do. Or apply simple, it's not KVL actually, but it is a sort of KVL. When you say V2 minus V1 over Vx, it is a sort of KVL, although we don't see it. What about the current sources? What about them, Alexa? They don't interfere. They have no influence, because at the end of the day, the voltage across the 12 kilo ohm is the voltage difference between the two nodes. We already found the nodes, which is V2 and V1. So it becomes V2 minus V1. This is the whole idea of the nodal analysis, because what we claim, and this is correct, of course, once I know every single node in the circuit, I can find any other electrical parameters in the circuit. So that is why we are finding all these node voltages, and then we will find every single current, every single voltage, every single power in the circuit by knowing the current flow in the circuit, and then we can find any other quantity if we want. Is that clear, Alexa? Okay, any other questions, guys? Any other general questions about the midterm if you want? If you understand everything I mentioned today, then it should be fine. You should be fine in the midterm. If you feel that there are certain concepts that's not clear for you, then you need to go and work on them. What time is it again? Okay, I will come to that. I will answer these questions. For the time, you have the window of the 24 hours. Once you logged in, you have 3 hours to finish everything, to submit the answers, uh, and then after you submit the answers, submit the PDF file. So you'll have 3 hours. For the multiple choice questions, it will be about sensors, data acquisitions, and maybe some little bit simple, very simple concepts in circuits. So these questions, like each one, should not take more than a minute. If you understand the notes, if you need to go back and read the notes, then they will take much more time. In general, does current flow, not general, always, the current flow from the higher voltage to the lower voltage. It's always the case like that. Any other question, guys? I will stop sharing now, and I will stop recording. So I will post this